Okay, so welcome to today's supplementary example on relative velocity. This example is number 7 in your handout package, and I'm going to do it twice. I'm going to first do it in this example using x and y components, and then in another video we'll do the exact same problem using sines and cosines. Just to give the idea, you can do it either way, whatever works best for you. The question then, in this case, is we're given a distance that a plane needs to land in at a certain time. And really that gives us an idea of what we call ground speed. That's where the plane has to go relative to the ground in a certain amount of time. We're also given in this question what the wind speed is, so how fast the air is moving. And so the question is then if the pilot needs to maintain a certain schedule based on the ground speed, and they have to fly into a given wind, then where should they aim? So I write here where the pilot aims. Usually with these problems, it's a helicopter. We usually use planes, so P standing for plane in the variables. So don't let that confuse you. Even though the question says helicopter, we're using P's for planes. But either way, where the plane or the helicopter has to end up is equal to where the pilot aims with a speed plus the wind speed. So we've done an example like this in class, but now we're going to do another one. So there's a couple of details we need to get through before we can start the problem. The first one is the idea of, well, what is the ground speed? PG stands for ground speed. And that's supposed to mean plane relative to ground. So that's the variables we use. In this particular question, we're not given that speed, but we are given the distance that he's got to travel, or the plane or helicopter has to travel relative to ground, and we're given a time. So it turns out then you can just divide and find out the ground speed. So this is ground speed. We're also given in the question, sort of right out there, we're given the airspeed. Okay? And we use the term AG for air relative to ground. That's what that means. So when solving the question, using x and y components, just like any other vector addition or subtraction we do, we have to draw the vectors. So I did that right away as I was listening to my notes. So airspeed is 38 north of east, so that ends up with, this must be my V, A, G, X, and here's the Y. Try not to let all the subscripts intimidate you. They just are, they're just there. They don't mean anything besides telling us exactly that that's wind speed. So in this question then, we're given the PG, where we figured it out as 91 kilometers per hour in the previous page. Here's the 91, so this is my PG, right? So we're given this one. We're also given the wind speed at 38 kilometers per hour, that's given in the question. And we need to find where the pilot aims in order to maintain their schedule. So we're looking for the PA. PA is always plane relative to ground, or sort of relative to air, and that means airspeed. So we really are doing this. This is what we're solving for. Really, we have to do a vector subtraction. So I take this equation, rearrange it to look like that, and I'm going to have to do a vector subtraction. As it is in 2 dimensions, we have to use x and y components, and I'll start setting that up over on the right here, figuring out all my x and y components. Okay, so doing this vector subtraction, I'm going to do it in the x direction and the y direction. We should start by listing what our positive direction will be, and just for the sake of argument, let's go ahead and say north and east are positive. Okay, did north and east positive. Here's my VAGY, my VAGX. This will be my VPGY and VPGX. Okay. Once you have that set up on your page, if you're using components, the next thing to do, to be clear, set up an x column, a y column, and you do your vector subtraction in the x, and you do your vector subtraction in the y. So I'll do that on the next page. So just keep in mind. The equation I want to end up using is that PAX equals PGX minus AGX. could very well be that the hardest thing about relative velocity questions is all the subscripts. Similarly, v, p, a, y equals v, p, g, y, and v, p. Okay, so what is what? V, p, g, x. If you look back to the triangle, v, p, g, x is opposite my angle, and it's in the negative direction. So, v, p, g, x will be negative direction, 91 sine 72. VAGX is in the positive direction, it's in the east direction, and it's 38 cos 25. Just take a quick look and see where I got that from. So here it is, VAGX, and it's adjacent by 25 degrees, my hypotenuse is 38. And that's where I came up with that. Similarly, on the other side then, V, P, G, Y. In this case, it's positive. Positive because it's west of north. And without even looking at the triangle, I've told you before that if this side's sine, this side must be cos. Remembering that the VAG is north and east, so that's all my positive directions. So now when I do my vector subtraction, V, P, A, X is going to be negative 91 sine 17, take away 38 cos 25, works out to approximately V, P, A, Y equals 17 minus 58 25, approximately 70.6. Positive. Okay. So continuing, remember that once you have your x and your y, you have to do a right angle triangle, and this is where you use we'll use Pythagorean theorem. When I draw my triangle, I'm going to draw my x first. You put your pen down, you start drawing the x, negative 61. Don't pick up your pen, go ahead and draw the y, which is in the positive direction. Then you start where you started drawing, draw a vector that goes to where you finished drawing, and this is VA. So using Pythagorean theorem, VPA is going to be the square root 70 squared. About 93.6. And my angle don't worry about putting negatives in there, you don't have to. It ends up being 49 degrees. So therefore, my airspeed, VPA, or airspeed, equals 94 kilometers per hour. You need decimal places. 49 degrees north of. See that? So here's my west. It's 49 degrees north of that. Okay. Let's circle it, check mark it, but before we finish, actually before I check mark it, really, let's take that check mark off. Let's just see if that makes sense in our brain. The thing about relative velocity is a fairly easy concept. You know, this is where the pilot has to aim. And so let's think about what the actual problem would look like. In this case, you've got a pilot that wants to end up over here. They want to end up 17 degrees west of north. That's where they want to go. But there's a wind pushing them to the east. So if the pilot was to aim, you know, say directly here, the wind would push them up here. So we know that basically we've got to aim down here so that we get pushed where we want to go. So it makes sense then that we go about 94. Okay, that number doesn't make a whole lot of sense, except for, or not sense, but what matters, what makes a difference, we know that we need to aim over here so that we get pushed where we want to end up. So it makes sense that we're going to be the 49 degrees here to push us up to 17. So now, check mark.